Magnetic effects of electric current I explained in my last video. After the discovery of magnetic effects of a current carrying conductor by Hans Christian Ørsted, Biot and Savart gave a law to determine the magnetic field, magnitude of the magnetic field at a point due to a current carrying conductor. This is a conductor and it is connected to a battery. So current is passing from the positive to negative of the battery. So this is the direction of the current. Then we have to find the magnetic field at a point P due to the current flowing through this conductor. Then the different parts of the conductor are at a different distance. This is away from the point. This is near to the point. So we have to consider a small element, a current element dl. So AB is a small current element of length dl. Then magnetic field at this point due to this current element is given by Biot and Savart law. Magnetic field here, because of the small current element, is dB. That depends on current flowing through conductor, current I, then length of the conductor, then sine of the angle between the direction of the current element and the line joining the current element to the point. So they are directly proportional. So magnetic field is directly proportional to the current, directly proportional to the length of the current element, and the sine of the angle between the direction of the current element and the line joining the center of the current element to the point. So this angle is theta, so sine theta. So directly proportional to these three quantities and inversely proportional to the square of the distance, where r is the distance between the current element and the point. So if it is point is here, magnitude will be more. If it is away, magnitude will be less. So it depends on the distance, square of the distance. So this is Biot and Savart law. dB is proportional to ideal sine theta and inversely proportional to the square of the distance. Then this proportional sign can be replaced by an equal sign after writing a constant. So dB is equal to k ideal sine theta by r square. Then for this k in a SI system, we can write mu 0 by 4 pi, where mu 0 is the permeability of free space. Then value of mu 0 is 4 pi into 10 raised to minus 7. 4 pi into 10 raised to minus 7 Henry per meter. That's the value for this mu 0. Then magnetic induction or magnetic field is a vector quantity. So there is a direction for the magnetic field here. So we can write in vector notation like this. dB vector. Instead of this, we can write a dB vector. Then cross product. It can be written as the cross product of ideal vector. Actually, current is a scalar quantity. But current through the small element can be considered as a vector, ideal vector. So here this is the direction of the current. Here this is the direction of the current. So the current element can be considered as a vector. So ideal vector cross r cap. So this is the r vector. But unit vector along this direction is r cap. So r cap, its magnitude is 1, unit vector. So ideal vector cross r cap. Now to understand this, you should have an idea of cross product in vector algebra. So now that I will explain now. A vector cross B vector. Now two vectors, A vector, B vector. Angle between them is theta. So two vectors, A vector, B vector. So what you are getting is also a vector quantity. So it will have a direction. Then its direction is perpendicular to both A vector, B vector. Now A cross B, try to push A to B with your right hand. See, thumb is in the upward direction. So this is the direction of A cross B. Or another way, Now see, imagine a screw. Now A cross B. So you rotate in the same way, tip will be advancing in this direction. So this is the direction of A cross B. So this is n cap. So n cap. So A cross B will be perpendicular to both A and B. Similarly here, ideal vector. So this is the direction of ideal vector. And then this is R cap. Now if you write it back it, you can write like this. dB vector. Now magnitude of ideal vector is ideal cross R cap. So magnitude of R cap is 1. Then angle between them is theta. So sine theta. Then this is ideal vector. This is R cap. So ideal cross R, not R cross ideal. Ideal cross R. Ideal cross R. So here magnetic field will be into the board. This is ideal R. Ideal cross R. So it is here field will be so perpendicular to both. This is n cap. So you can write back like this. So this is giving the direction. So magnitude of, now using right hand rule, thumb rule, also you can get a see direction of the current is, so here field will be into the board. So this n cap is directed into the board. This is ideal vector. This is R cap. So field is into the board. So in vector notation, this is the Biot and Savart law. It is giving the direction of the magnetic field.